Okay, in the last video, you showed me placing this screw and putting it here in the assembly file. And if you noticed, I had mentioned there were some things we needed to suppress and possibly turn off. And what it was the actual sketches that mcmaster used in SolidWorks to create this part, or this screw in this case. Well, the way you turn these features off, or you turn the sketches off, which is kind of an annoyance, but it's typical when you get and work with mcmaster, although they make some really great products and some great models that you can work from, which I highly value. But still, you got to come in and turn off their sketches. Here's how we do that. We'll go back over here to the assembly. We'll go back and we'll look at that screw itself. Now, I've gone ahead and opened this guy up. And essentially what I did, if you take and expand each feature over here in the feature manager, you'll see a sketch. Now, if you notice here, see where it says show. Well, that means I've already turned that feature off. So I'm going to go ahead and show that again, and you'll see the sketch pop up. I'm just going to kind of go down here, and I'm going to open up some more of these. Again, I turned the eyeball off, and there was that. Let's see if we can get this guy up here. That's got to hide. Okay, that's in. We'll go to revolve. Let's see if that sketch is on. We'll go ahead and show that sketch, and we'll come down here to the sketch feature. We'll turn that guy on, and we'll come over here to this particular slot there, and we'll turn that guy on. Now, again, this guy here just has all these turned off, so I'm going to go ahead and quickly go back over to the assembly, and let's see if it reflects here. Nope, it doesn't. So when I originally turned them off, they stay off. So apparently that's some kind of way they handle that when they translate from the older version to the new version. But suffice to say, if you have sketches that come up from mcmaster model, you go back to the original part, as you see here, and you open it up and you expand each extrusion or cut, revolve, whatever, helix, whatever, and you go back and you right mouse click and you turn that feature off or suppress it. So I'm going to go ahead and hide it anyway because I want to make sure that they don't come back up. So that's good. Do a rebuild on our model. We'll go ahead and save our model here, and we're going to go ahead and we're going to place that screw in the actual bookend assembly, and we're going to get that saved. So now I'll go back over here to my assembly. We need to save that assembly too while I'm thinking of it. Oh, see, there they are. They're all turned back on. Okay. Well, we'll go back and correct that now. So we'll go back over here to Window. We'll go back here to our painted screw. And it doesn't show it in here, but we'll come back over here and right mouse click. And wherever we see an eyeball that says show, we won't click on it. But if we see one down here, click on that. It says hide. We're going to hide that. So that's hidden. Come back down here. That says show. Apparently that's still hidden. Go down here. See where it says hide. That sketch was definitely on in the assembly. We'll turn that off. We'll come down here to sweep. I don't think that sketch, that we already turned off. Let's go to the extrude, revolve cut, and that one we definitely want to hide, turn that off. And this last sketch here, we want to definitely hide that. So again, we'll rebuild our model, save our file. We'll come back over to our assembly, and there you can see I've got them all turned off. That's good. So rebuild this model here and go ahead and save the file. Now, what we want to do now is do a concentric. We want to do a coincident mate and concentric mate. Well, first let's do a concentric mate of this surface here, or excuse me, that edge of that screw hole with, let's come up here and scroll around, see if we can find a round part of this. I'm gonna grab this guy right there. And so what it does is it concentrically mates that, but the problem with it is the screw's upside down. We got to fix that. So I'm gonna come over here and I'm gonna see if I can change the alignment, and there it did. Now this also confirms another issue. If you notice, the screw hole is a little thinner than the actual screw itself. Well, this is an 1/8 inch diameter screw. Excuse me, it's a little more than an 1/8 inch diameter screw. But what I'm going to do to prove that point, I'm going to go ahead and mate this to the surface of that base plate. So I'll select on that. I'll go ahead and hit mate, and then I'm going to go ahead and rotate this around using my center wheel on my mouse, pushing down. I'll click on that, and it's going to go ahead and set that guy down in there. So that looks pretty good. Now, one of the things we got to do here is we got to make sure that we have enough clearance on that screw hole to actually get that screw in without stripping all the threads of it off. So the way we do that, again, this goes back to one of my laws of how I like to design, is you always design to the materials and the tooling that you have? Well, one of our tools are drill bits. So we can bore the size of that hole out even further if we knew what the next size was to bore it up to. The only way we're going to know that is we're going to have to come over here and we're going to have to do a section cut. Now I've already got it set to the front plane section cut, and now if I grab this arrow I can slide this over, and I actually kind of already pre-positioned myself before I did this to kind of look at what I was doing, kind of choreographed it. So I got to kind of position right down the middle of the screw and the screw hole and accept that. Now I'm going to go ahead and click on that face and set myself normal to that face, that section cut face. And if I come up here, you can definitely see the problem we're going to have. The problem we're going to have is these threads are definitely going to get scarred as they go through. You could probably force that in and make it fit. I wouldn't do that. So the best choice we can do is to probably go ahead and rotate out, and let's take a quick measurement on this other hole. So I'll grab my trusty tape measure from the evaluate command. I'm going to deselect that. I'm going to grab that edge. So that edge tells me that the diameter of that is looks like 0.15635. Okay, so what do? Well, here's what we do. We'll come down here and we'll go to richardplatt.net. We're going to open up that, and we're going to come over here to our home button, and we'll go back to home, we'll go back to Southeast Engineering, and we're going to come down here and we're going to click on reference. So the first thing I'm going to look at is the decimal chart. So it said that it was 1.56 so in diameter. So what I'm going to do is I'm going to come down. That's basically 5/32. So probably the most next logical size to come up. You can get a 9/64 bit. I use 3/16 drill bits all the time. So that's one I'll commonly have in stock or in my toolkit, or I'll go buy a lot of 3/16 because I use those typically with an 1/8" screw. So it gives me a little bit of play. Also gives me room to put some glue down in the hole if I want to glue that, which in this case I would. So we're going to put a 3/16 diameter hole. All right, no biggie. So we're going to come back over here to our SolidWorks model, which is this guy right here, and we'll get out of this, and we're going to go ahead and leave that section cut in play. We're going to click on the steel plate. We're going to open that part. So you got these cut extrudes over here. So I'm going to come over and I'm going to look at those sketches on the cut extrudes. Actually, that was for the cut on the that was for the cut on the bead line. So I'm not going to use that. Let me get out of that real quick. Go back over here to my boss base extrude. I'm going to edit that because that's where the diameter of those holes are. So as you see here, I've got the this hole set to 1.56. I guess I was anticipating that. I'm going to go ahead and double click on that measurement, and I'm going to key in 0.1875, which is 3/16. And I'll change that, zoom out a little bit, and let's change this one here as well. Double click on that. Double click, 0.1875, click on that. Now let's see if that is reflected over here, because I think I did a copy mirror on that, but we'll need to check it anyway. So I'll get my tape measure and we'll get a measurement on that. And yes, it did. It did reflect it. So that relationship was constant. And when I did the copy mirror entities, it kept the relations on the side. So now that's 3/16. That's great. We'll go ahead and get out of that. We'll go ahead and rebuild our model. Fix that real quick. Save the file. All right, hit an F command. Save it one more time, and then I'm going to come back over to my assembly. Now, on my assembly, it's going to ask me to rebuild. Of course, I'm going to rebuild. So I hit rebuild on that, and if we come back up here and check by setting ourselves normal to that, face on the section cut, you definitely see we have clearance to put that in there. Yeah, it may be a little bigger, but I'm not going to go buy a 9/64 drill bit so I can put that in. They're kind of hard to find. So 3/16 definitely is one I can find. Again, we're designing and manufacturing to our tooling. Plus, if I wanted to, I could put epoxy down in that hole and fill up that gap, and it makes it even more stronger. Notice also the depth of the screw itself. We may, when we put these plates down, come in and put a pilot hole in before we actually put these screws in to get a better seat on that. However, that looks wonderful. I like that. But now let's get rid of that section cut, and we're going to put that screw in all these different holes. And we also need to come back quickly and modify that particular plate as well. So let's stop for now. We'll come back to that. I'm going to go back and modify all those holes, by the way.